All right, good morning. Advent of Code day 3. Sorry, I've got a cough drop in my mouth, a little sore throat, but we're going to get this thing started. For those of you that have been following along, I've already created a day 3 file. I've already switched my main to be calling day 3. So let's get into the puzzle. All right, login problem solved. Set off towards the airport. Due to the local geology, trees in this area only grow at exactly integer coordinates on a grid. You make a map for your puzzle input of the open squares and the trees. You can see, okay? These aren't the only trees though. Due to something you read about once involving arboreal genetics, blah, blah, same pattern repeats to the right many times. Okay, so you can see there's like a repeating pattern here. Okay, you start on the open square in the top left corner and need to reach the bottom, below the bottommost row in your map. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope, right 3, down 1. From your starting position at the top left, check the position that is right 3 and down 1, and then check the position that is right 3 and down 1 from there, and so on until you go past the bottom of the map. The locations you check in the above example were marked here with a 0 where there was an open square and X where there was a tree. Okay. So I started here, so 1, 2, 3, down 1, 1, 2, 3, down 1. Okay. In this example, traversing the map using this slope would cause you to encounter 7 trees. Starting at the top left corner of your map and following a slope of right 3 and down 1, how many trees would you encounter? Okay, so immediately I'm thinking 2 things. We need an array that does wrapping, so it goes around the end and comes back to the beginning if you're counting left to right. That's why they did this infinity thing, is because I'm sure marching the right 3 and down 1 will march me off the side of the map. And then the rest is just an array of arrays. And the only thing weird about working with an array of arrays is that you do y index first instead of x index into your array. You'll see that in a second. How many trees did you encounter? Okay. Normal. Okay. Equals the input. Okay. So there's our input. Okay, and so we want a wrapping array or a wrapping index into an array. So let's parse this first, one problem at a time. So part 1. So our input is we need lines, and so what we're going to do is we're going to say equals we want input dot split on the new line character, same as we did every day so far, and then this gives us a string subsequence. This is so hacky, but okay. So we're going to cast it to a string and then an array. Really? See, this is what happens when I try to get ambitious with strings. Can I just cast this directly to an array? Oh, it already was an array. Duh. I'm trying to get an array of characters. Substring. Do I have to label this? I don't know if you remember, but I went through this headache in day 2. No, you can label it. Huh. Oh, I'm so stupid. It's an array of substrings. So I've got to map it to strings because it's not a single substring. This is what happens when you do these either late at night or first thing in the morning. So now I have an array of strings. Yep. And this is the one that I want to turn into an array. Yeah, this is why you don't program while sleepy. An array of string elements, which is going to be characters. Okay. Easy. Okay, so what we want to do is we're going to start at, because we're going to march one row at a time, so we don't really need to keep track of the Y. The Y is, actually we can probably even do for each line in lines, because we're going to go through every single one of them. That's like part of the requirement. And then we're going to do x equals 0, because that's where we start, is on the 0th index. And so they say you start there and you go 1, 2, 3, 1. I should read this more carefully here. No, see, okay, so it ran over trees here and it's not marking them. It says we only ran into 7 over the course of it, which would be way more if we were counting the trees we ran over. Okay, so first thing we want to do is x plus equals 3 over 3 down 1. And then I actually want to skip the first line. Okay. Lines dot remove at 0. Okay. We're skipping the first one because you don't. It's 3 down 1. Okay, this might bite us later depending on what part 2 is. We'll see. Okay, so over 3 down 1. Okay, so then what we're going to do is we're going to say if line sub x equals a hashtag, then we're going to increment our count. So we're going to encounter one more tree. Let's name our variables nicely, shall we? Okay. And we're going to go through every single line. And we're just going to keep marching x over. Now, the one thing that we need to do is we need to say, if we've added 3 to it so many times that we're going to run off the edge, we just need to flip back to the beginning. So if x is greater than or equal to line.count, because line.count is technically 1 over, so we need the equals here. It's greater than or equals, then you x minus equals line.count. I think that's right. So this is how I think about these sort of problems. Okay, so this is what I've got. I got 1, 2, 3, 4, 5. Okay, so if I'm right here on index 0, 1, 2, 3, I'm on index 3, and adding 3 would overrun it. That would put me at 1, 2, 3. So what I need to do is that would actually put me at index. So I started at 0. Okay, 0, 1, 2, 3. Add 3 to it. 4, 5, 6. And then I'm going to subtract 1, 2, 3, 4, 5. I'm going to subtract 5 from 6, which puts me back at 1. That's not what I want, right? I don't think that's right. What I'm going to do here, first time I'm using a breakpoint because can't remember exactly how I want this to work and my brain's not working this morning. I'll put a breakpoint right there, and we're just going to, the first time it hits it, I'm going to see what it ends up evaluating to and make my decision based on that. Okay, run, baby. Boop. Okay, so x is 33, run off the edge. So x was 30. How many are in a line? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 30, 31. There's 31. Okay. So it's overrun it by 2, which means it should be back at index 1, and it's at index 2. Okay, I think that's right. That's what I would expect, I think. Okay. Let's try this again. So it gets there. It was at 30. 1, 2, 3. So index 1. X is now index 1. I think that's what we want. Okay. And so now the last thing we need to do is we need to print trees. How many trees did we find? I think that's all it wants from this problem, right? Did I overrun it? Index out of range, -1. Okay, so I can't do so in this case x went negative. Ugh, I hate wrapping arrays. Is it just this? Ooh. That might be it. No, that's not it. Okay, yeah, because it does have to be greater than equal. I'm not wrong about that. So I guess the problem is, I guess we can find out how far it overran it. Okay, let's do this again here. And this is clearly not right. Okay, so what I need to do is figure out how far it overran it. So x33, so line.count is 31, right? I don't know why I counted before when I could have done that. Okay, 2. So it's overrun it by 2. So x minus line.count is 2, which 1, 2. So I think what I think I actually want is I want x equals, yeah, I do. Well, the problem is when it lands exactly on 0. Because when it gets 33, okay, this is just, my brain is not working this morning. There's going to be like some stupid operator that's super clean that tells me to range of count and then add count back into the mod again. Index mod the count plus the count. What? Let's see if that's the case. Where it's x and it is line.count. This seems like I would have imagined there would have been a simpler version of this. Wrapping array, this even looks sort of swifty here, but it's the same. Okay, so take the index, mod it by line count, and then add that to line.count, and then mod that by line count again. So this is get the remainder, add it to the line count. Okay. Hopefully my brain's caught up by part 2. Here we go, taking an answer off the internet on how to solve a wrapping array. We'll see if it plays out for us. It totally works. Okay, let's think harder about that once we get to the end here, since this is timed. Okay, time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop after all. Determine the number of trees you would encounter if each of the following slopes you start at the top left corner and traverse the map all the way to the bottom. Right 1 down 1, right 3 down 1, right 5 down 1, right 7 down 1, right 1 down 2. In the above example, these slopes would find 2, 7, 3, 4, and 2 trees respectively. Multiplied together, these produce 3, 3, 6. What do you get if you multiply the number of trees encountered on each of the listed slopes? Okay, so this is just same thing, but we need to generalize it. So we're going to create another func that is called down the slope, down right. Okay. So far, and then lines, an array of string dot element, I think is what it is. It's not technically characters. Okay. Okay, so what we're gonna do here, this is lines X, this is right, and then we're gonna have to fix the down. So then what I should be able to do is, we're skipping the first line already, but maybe we don't want to do that. Yeah, we probably don't want to do that actually in this anymore. So what we want to do is for I in down, because we dot less than line dot count lines dot count. So this is going to go down, and then this is going to go left and right now, and so now we have line equals line sub I. Okay, so I think that gets us the down behavior. Let's see if we still get 195. Down, whoops, this is not a class. Down the slope, lines down 1, right 3. Is that what we originally did? Right 3, down 1. Line was never used. Oh, yeah. Boop. Okay. There we go. Down slope 195. Okay, so that still works. Okay. So what we want to do is we want to okay, so we want to get a new value that is the value of all of those together. So our solution is going to be this, and then solution times equals this. Is there 4 of them? 1, 2, 3, 4, 5. There's 5 of them. Okay. So right 1, down 1, and then we'll figure that out in a second. Oh, this needs to return an int. Return trees. Okay. So right 1, down 1, right 3. I'm already regretting doing these in the wrong order. Right 3, down 3. Right 5. Right 5, down 1, right 7. Right, 7 down 1, and then right 1 down 2, and then I have 1 too many. And then we print the solution. Okay. Whoa. Looks big. That's not the right answer. Oh, what did it say? The answer is too high. Okay. Oh, let's think more critically here. Okay. So, first things first, I'm gonna flip this to be right and down because I'm already annoyed that I did it backwards, and so I need to redo these. Why am I living like this? Okay. So it is right and down. Right 1, down 1. Okay, right 1, down 1. Right 1, down 1. Right 3, down 1. Right 5, down 1. Right 7, down 1. And then right 1, down 2. Oh, I'm gonna bet it's the last number because I'm not striding appropriately. Because I do need to start it down. There's like a stride thing. Swift for a loop stride. I use this so rarely I do not remember. From 0 to 10. Okay, let's try that. It's just 4 in stride. Okay. 4 in stride from down. Yeah. To lines dot count by down. Okay. I think that'll change the last number and the rest should be the same. I'm actually going to copy these so that I have them for later. So I can compare them. 84, 195, 70, 70, and 47. Yeah, so it was the last one. There we go. Okay. Let's look at the problem here really quick. I want to be a little bit smarter every day, so let's understand this. Okay, so in this case, so what we were doing here is the problem we ran into was 33, and we needed it to wrap back to 1, and then we also had 30. Those were the two, or 31. Those were the two indexes that were giving us trouble. Was it 31 or 30? We'll look at all of them. I can't remember which one was giving us the actual issue. I think it was 31 though. Okay, so if x is 33, 33 mod 31 is 2. K is 2 plus line count is takes us back to 33. Oh, okay, so that's like, that will get us, and then, wait a second, what? I really don't understand this. And this is never a good idea to have stuff in your code that you don't understand. Index equals this. Okay. So let's take this first part here. Index equals index. Just splitting this into two functions here so that we can try to understand. If index does not equal x, Okay. Okay, so index went to 0, x was 31. Okay, so this was one that was giving us problems here. So x mod line count plus line.count is 31. And x was 31. See, that's the part that I don't understand why you do that at all. So let's say that PO, let's say x was like 5, so it was a totally valid index. See, that's the part that I don't understand. Oh, interesting. So 5 line.count is 5. What's line.count? It's 31, right? I'm not insane. 31. Okay. So this, so PO32 mod line.count. Yeah. Okay. So the first part of this is basically saying take x, and if it's less than our line count, so if it's, you know, in a valid range, then leave it as is, because basically the mod is like the remainder operator, right? So like in this case, 5 divided by 31 is 0, remainder 5. So that makes sense, right? Like it's leaving that alone. And then we are re-adding it to line count. That part I don't get, but I'm assuming it's valuable. That takes us up to 36. Okay, and then index mod line.count. So 36 mod line PO 36 mod line.count takes us back to 5. Let's see. Did I already do X in this list? Yeah, 31. So I guess what I'm trying to figure out is, this is totally like brain not working in the morning. Why doesn't this just do it for us? It's probably because of the case where 31, right? So like if I do 30 mod line.count, PO 30 mod line.count. Yeah, so that's still 30, and then the problem is going to be 31, right? No, 31 goes back to 0. So why is that a problem? Oh, it's probably because what if I have 62 mod line.count? No, that's fine too. Why do I need that second part? Wrong thing. Did they actually explain this in the answer? You can use the mod operation. Will get you a range of count to count and then add back and mod again. Oh, is it to handle negative numbers? PO -6 mod 30. Yeah, okay. It's to handle negative numbers. It's so you can wrap both directions. Because that makes sense. Because if you do that, you've wrapped the wrong direction and then you have to add back in the line count. Okay. Got it. So that basically, so So that totally makes sense. So basically, if you knew that it's only going to wrap to the right, you can just do this part. But if it needs to be able to wrap to the left, then you got that part. Okay, got it. Learning. And see, this is one of those things where like I'm actually let's try and improve my solution, right? Let's see if this works because we're only marching to the right. Yeah. Okay, so I was right there. That like if you're only marching to the right, you only need the first half of that equation. The second half is for wrapping to the left. Cool. Learn something every day, and that's also usually when you have coding problems like this, usually it's pretty well defined, and so like I've only ever thought about this problem marching to the right. So there you go. It's also probably why you need good QA on your team, because of course QA would try to access the -6th item in a list, and you would have more robust code for it. Okay, so that's part one. This one's part one, and then the whole thing is part two. Kind of weird. Okay, well, hopefully you guys enjoyed this one. Hopefully you learned something like I did. That's pretty awesome to see this. And like I said, I think that's part of why we do admin of code rate, so that we can learn something and add that to our toolbox. And I'm going to guarantee that I won't remember this exact formula the next time around, but I will remember that that you have to check going both directions for array wrapping, because I think this is maybe one of the first times that I've just straight up Googled the solution to line wrapping array. Usually you're in like a programming interview or something, and so you're trying not to use the internet at all, and so you have to pull it out of your brain. But anyway, that's awesome. Okay, well, thanks for joining us. Again, if you want to come in, learn something as we're hastily going through some programming puzzles, make sure you like and subscribe. We're going to be doing this every day with all of the admin puzzles, so look forward to seeing you on the next one. See ya.